Hello viewers, how are you and good day. This is my third video pertaining to my design of perpetual gravity wheel. It's version 1.2 and today I'm uploading this third video, and this is basically a slight improvement in my previous design. For the new viewers, I'll just tell you what all it comprises. This is a large wheel. I have designed this software, designed this prototype in Algodoo simulation software, which is basically a physics engine. This is a wheel which is connected on this back block through an axle, and it is having a rim running close to its circumference, and there is a small wheel which is placed inside, but it tends to roll down to this point due to gravity, but because the axle of this wheel is connected to this lever, which is again connected using an axle to this back block, so it remains at this position. And then in the center of this axle I have just added two inverted pendulums. The main purpose of this optimization was to increase the RPM. So I've reached around 2.7 or 2.8 radians per second for this larger wheel, and approximately 20 radians per second for this smaller wheel. First of all, I should tell you the material I have used. This larger wheel is basically having a mass of 20 kg. The friction is set to standard 0.74 for this. The material is steel. Now, previously I used concrete, but this time I'm using steel. For the circumference, this rim, again it is 20 kg, and the material is steel, and friction is 1. For the smaller wheel inside, the material is same, the steel. The mass is 100 kg. This is very important. Previously I had the mass, I used it as 200 kg. At that time I didn't use two inverted pendulums, so this time I've reduced it from 200 to 100 kg, and I used this inverted pendulums now, and they are having the mass 50 kg each, so the total mass remains the same. The pull, the downward pull is the same as 200 kg, and again it's 50 kg. So let me show you. I am not using any self motorized axle. Again, this is the axle. Again, the motor function is unchecked. So let's run the simulation. Now this wheel is trying to roll downward just to achieve the state of equilibrium, but now it has started spinning in clockwise direction. I don't know why. It is having a very weird sort of spin. So sometimes it moves anti-clockwise, sometimes moves clockwise. So now it's spinning clockwise, and because of this friction, the big wheel also tries to bring the state of equilibrium. So it's just like a person who is standing on a tilted treadmill, a manual treadmill, with the roller board under his feet, and the treadmill is moving, the rollers of the board is also spinning, but the man is tied up with a rope back to a trunk of a tree. So I don't know whether it's an error in the Algodoo simulation software, but it seems quite convincing that this idea can be materialized. Okay, let me stop it. First, let me lock both the wheels, and now I am again running the simulation. Now I erase these two locks, this one too, and now I try to spin it in anti-clockwise direction. Let's see that what happens. And now let's check the plot of the bigger wheel and that of the smaller wheel. And let me change the y-axis to show the angular velocity. Okay, this is larger wheel, this is smaller wheel. Now you can see alright, now you can see it, now it's spinning anti-clockwise, and the angular velocity for the larger wheel is now close to 2.7 radians per second, and the average angular velocity of the smaller wheel is 20 radians per second. Okay, now let's speed up the simulation rate and see what happens. Okay, sorry for my landline. Still spinning, and there's a slight variation between 2.7 radians. Yes, 2.7 radians per second. Previously I achieved, I think, 2.4 or 2.5 radians per second. Okay, so that's it. If anyone can design a prototype for it, you all people are most welcome, and I appreciate your interest in my video, and I also appreciate that you just give me a recognition to my design by naming it Ali_Gavvi. So best of luck and have a nice day.